chapter, we are going to talk about some properties that work with logs. And then we're going to apply those properties in a few different ways. And you will see these properties, especially the third or the final property. There's three main properties. I'm going to show you some other little ones in between. But you'll use these a lot, especially the power one. So the more you familiarize yourself with them right now, the better off you're going to be long term for the rest of this chapter. So starting with a few properties here. With logs, I want you to take a look at this. Okay, I think you can tell me what this equals. 1, right? B to the first power is B. So log base B of B will always be 1. That means if your base and your number right behind your base are the same, it's always an answer of 1, okay? Let's switch that around a little bit. Log base B of 1 is what? B to what power is 1? Not B, 0. Anything to the 0 power is 1, okay? Now here's the deal. It doesn't matter what your base is. Anything that says log 1, log base 2 of 1, log base 5 of 1, log of 1, what's the base right now? 10. All of them are 0 because anything to the 0 power is 1. Okay? So when you see log 1, it's always going to be 0. How about this? Log base B of B to the x. What will that equal? X, right? B to the x power equals B to the x power. Okay? So these are all things that, like, I feel like at this point you're like, yeah, I know that. Great. But they're just things that you need to make sure you're thinking of as you solve these because they come into play a lot. Okay? The new ones, the ones you don't know, are these three. So the first one is this. If I give you log base B of m times n, okay, it will equal, we're going to break the m and n up, m and n, sounds like M&Ms, into two separate logs. So it's log base B plus log, oh, sorry, I missed my m. Take that back. Log base B of m plus log base B of n. And if you recall, we've done this before just with exponents. Logs are exponents, which is why this works. If you think of it like this, right? In the past, we've done x squared times x to the third. That's equal to what? X to the 2 plus 3. That's a 3, not a 5. So when you're multiplying, you're actually adding, right? Or vice versa. If you're adding, there's multiplication if you separate them, okay? So we're going to be able to use this one both ways. Sometimes you'll see it like this, and you'll turn it into this, and sometimes you'll see it like this, and you'll turn it into that. But here's what I want you to remember about this. When you are doing a product, you're going to do addition. Okay, so multiplying m and n, you add the two logs together. What if it's a quotient instead? What's quotient again? Division. So if I say log base B of m divided by n, what did we do with exponents when we divide? We subtract. So that's what you're going to do. You're going to subtract. Okay, so this will be log base B of m minus log base B of n. Okay? Make sure you just keep them in the right order, right? M over n means m minus n. You can't flip that. Okay, then this one. This is probably the one you use the most when dealing with a power. So if this is log base B of m to the n power, what happens with this is that power is going to get taken and put out in front of the whole thing. So this becomes, this n is going to drop in over here so that we can ditch the power and call it n times log base b of m. Here's why this works. Think about it like this. If I have log base b of m to the third power, right? That would be log base b of m times log base b of m times log base b of m, right? That's log base b of m to the third power. Essentially what I'm doing is I'm multiplying that number 3 times, okay? So you can take that exponent and just move it out in front instead, okay? And like I said, you're going to use this property a lot, so get really familiar with that. When it's an exponent here, you can move it out in front and make it the whole number out in front, okay? All right, let's do some. Example number 1. For this first batch, we're just going to simplify logs. Okay, so if they tell you to simplify, this is what you're doing. It's going to look something like this. For the first one, let's say we have log base 3 of 20 minus log base 3 of 4. Okay, now for some of you, it might be tempting to say, oh, sure, that's log base 3 of 16. You cannot just subtract the 20 and the 4. It doesn't work that way. Instead, with subtraction, come up here. When we're subtracting, if we do that in reverse, because I said you can do all these in reverse too, right? What are we actually going to do with those two numbers? We're going to divide them. So we're trying to get it down to 1 log, okay? That means we have log base 3 of 20 divided by 4 is the way we can write that. Simplify that, you get log base 3 of 5. And that is your simplified log. Questions on that? All right, let's try another one. Let's say we have 3 log base 2 of x plus log base 2 of y. And just a little side note here, the only time you can use these properties is if your base is the same. So because these are both base 2, because those last ones were both base 3, we can do this. If they don't have the same base, you can't do any of these properties, okay? All right, so we're going to simplify. This is addition, right? We're adding. So what are we going to turn this into? Multiplication. But now here's the thing. We're actually using 2 of our properties here, because if you notice, there's a 3 out in front. So if there's a 3 out in front, if you look up here, where do we need to put that 3 when we simplify? The exponent. So we're going to take this 3 and we're going to make it an exponent to our x, okay? So I'm going to do this in 1 step, but if I lose you, tell me and I will break it down into the 2 steps if I need to. So it's log base 2 of x to the 3rd times y. Does that make sense? I took this 3, made it an exponent. I took my 2 things here, and I multiplied them together because we're adding. Still with me? Yeah? Okay. All right. That's your answer, by the way. Next one, letter C. We have log 2 plus 3 log 4. Log 2 plus 3 log 4. Okay, so we're adding, which means we're going to do what with our numbers? Multiply. So when you're adding, you're going to multiply. Notice this 3. Where's that going to go? Exponent. We're going to take it and we're going to move it to an exponent to the 4. So it's going to be log 2 times, because we're adding, we're actually multiplying, 4 to the 3rd power. okay? And we're taking the log of all of that. That's going to be one number. You're just going to simplify that number. What's 2 times 4 to the third power? Anybody? 128. This is 64 times 2, so it's log 128. Isn't that fun? I think that's so fun. I love it. Okay. Letter D. We have log base 4 of 5x plus log base 4 of 3x. Okay, so think properties. We're adding. What do we need to do? Multiply. So we're going to do log base 4 of 5x times 3x. What is 5x times 3x? 15x squared. So your answer is log base 4 of 15x squared. Okay? Any questions on that? Okay, so that's simplifying logs. Now we're going to go the other way. We're going to expand logs. So you're going to have this simplified, and we need to turn it into an expanded version. Here we go. Example number 2. I can't hear you. The last problem? No. We're here. Told you, it's a slightly longer lesson. These are not the simplest, so the more practice, the better. All right, expand logs. We're going to expand these. Letter A. Let's say you have log base 5 of x divided by y. Okay, so think of your property. What should we be doing when it's division? Subtracting. So we're going to break it up. Log base 5 of x minus what? Log base 5 of y. And that's your answer. Just expanding it so that you only have one thing with each log. Letter B. Let's say you have log base 3 of 5r to the 4th. Okay? Now, this one, I feel like people forget the last step of this one. So we're going to break it up twice here. Okay? You want one term, not one term even. You want one letter or one number with your log, with each log. Okay? So if we break this up, this is multiplication. With multiplication, what should we be doing? Adding. So it's going to be log base 3 of 5 plus log base 3 of, and we're going to just call this r to the 4th for now. Do you see what we need to do for our last step? Move that 4, right? So I don't need to see that as 2 steps. If you can do it in one, that's totally fine. Log base 3 of 5 plus this 4 is going to move out in front as 4 log base 3 r. Okay? Letter C. We have log base 2 of 4x squared. Just when you see exponents, think I'm not done with these. If you have exponents, you're not there yet. Okay? Divided by y. So you have 3 different pieces here. You have the 4, you have the x squared, and you have the y, which means we're doing multiplication, 4 times x squared, but we're also doing division. So what are we doing? Addition and subtraction, okay? So this is going to be log base 2 of 4 plus, it's log base 2 of x squared. Can I do that in one step and move my 2, or do you want to see it as 2 steps right now? One step is okay? Do you want 2 steps? No one's going to say if they do. I'm going to do it as 2. Because you feel like you stand out if you say yes. So it's log base 2 of x squared, and then it's minus, because the y is being divided by, log base 2 of y. Okay? The only thing you need to do with that, this will stay the same, log base 2 of 4, plus, we're going to move this 2 out in front. 2 log base 2 of x minus log base 2 of y. That would be your answer. Okay? Letter D. This one is log y over 3 squared. Okay, what's your base right now? 10. You don't need to write base 10 in, right? It's assumed base 10, so don't worry about writing a base in. But notice you have 2 things that are squared, right? The y is squared and the 3 is squared. So you can think of that separated if you want. Call it log base, you don't need base, log of y squared divided by 3 squared, if that helps you to see it that way. Or you can start with the subtraction part of it and deal with the squared at the end. Because we're dividing it as subtraction, I like to just put that 2 out in front of both of them right away. So I would say this is 2 log y. What's going to come next? Minus, we're dividing 2, God bless you, log 3. Okay, and that's your answer. You see how I did that? I put the 2 out in front for both of them, right? Because the 2 is going to both of these numbers. Okay? All right, last one of these, and then we will jump to the next example. This one's a little bit unique. This one has a radical in it. Okay, log base 2 of 2 rad 3a to the 7th. Now, when you see a radical in there, a square root, for instance, is what power? The 1/2. So I would rewrite this as log base 2 times 3a to the 7th to the 1/2. Okay? Because then you can think of it a little easier as the separate pieces. So I would probably, for those of you that you can do this in your head as like 2 quick steps, that's fine. I would probably rewrite this a little more expanded before I expand the whole thing. So I would call it log base 2 of 2 times, this would be 3 to the 1/2 power, and a to what power? 7/2. Okay, so now we can break it up a little bit easier. You're going to do this 1/2 is your power. That can go out in front of your log, right? So starting here, log base 2 of 2 plus, because we're multiplying, put the 1/2 out in front, 1/2 log base 2 of 3, okay, and still multiplying, plus put the 7/2 out in front of your log, 7/2 log base 2 of a, okay. Now there's one thing here that we can still simplify. Does anyone see it? Not the half. The what? The 2 and 2. Log base 2 of 2 is what? It's 1. 2 to the first power is 1. So really simplified, you can call this 1 plus 1/2 log base 2 of 3 plus 7/2 log base 2 of a. Whew! How about that? You like that? Yeah, I like that a lot. There's a lot going on, I know. Okay. Deep breath. Here we go again. Okay, example 3 is evaluating. This is what's left. There's 4, yeah. All right, this one, we are going to evaluate. Whenever we evaluate, that means you get a number answer, right? We're going to evaluate. What does this work out to? And there's kind of multiple ways that you can do this. I think one of them is easier than the other in most regards, but you can do it your own way if you like your way better. Here is the problem. 3 log base 2 of 2 minus log base 2 of 4. Okay, so we are trying to come up with a number answer. Now here's the thing. What did we just say log base 2 of 2 was? 1. So really this is 3 times 1, right? That's beautiful. What's log base 2 of 4? 2. 2 to the second power is 4. So this is just 2, which means our problem is really 3 minus 2, which is 1. Okay? Now if you don't like that way, that's okay. You could turn this whole thing into what we were just doing. I think it's way harder. You might disagree with me. We're subtracting, right? With subtraction, you do what? Divide. So you could turn this into division. You could turn this into, why would you want to do that? I don't know, but some people like to. I wouldn't like to. This would be log base 2 of 2 to the third, right? This 3 would come over here, over 4. So log base 2 of 2 to the third, 8 over 4 would be log base 2 of 2, which is 1. Okay, so you may do it this way if you like that way better. I just think, why not just come up with what each one is individually when they're that small? But again, totally up to you. Sorry if I'm projecting my preferences on you. Yes. Remember how we set up logs in exponential form? We say this number, 2 to what power is equal to this number? Right? 2 to what power is 4? 2 to the second power is 4. I know there's a lot of properties coming into play here, huh?
So it's like a 2 and then a 9 would be 3?
No. If it was a 3 and a 9, it would be 2. Log base,
2 of
right. If it was log base 3 of 9, your answer would be 2. But 2 to the third isn't 9. You're saying if this was a 2 and this was 9? Yes? So the question is 2 to what power equals 9? There's not a good, right? If this was 8, then your answer would be 3. Oops, 8. Then it would be 3. 2 to the third power? Yeah. Okay, letter B. This one is, let me get this out of the way so we don't run into it. Log 1 plus log 100. Okay? What is log 1? 0. Remember, log 1 is always 0. 10 to the what power equals 1? It's 0. So I would do, this is 0, plus log 100 is saying 10 to what power equals 100. So what is log 100 equal to? 2. 0 plus 2 is 2. Okay? I would do it that way. You don't have to do it that way. You could do it log 100 plus, log 1 plus log 100. You're multiplying, right? So that would be the log of 1 times 100, or log 100, and we just said log 100 is 2. Okay, so if you want to do the expand in reverse, so simplify, you could do it that way too. Okay, letter C. This one is 1/2 log base 5 of 1 minus 2 log base 5 of 5. Okay, again, I still think it's easier here just to take what these logs equal. What is log base 5 of 1? So 5 to what power equals 1? 0. Remember, log 1, any log 1 is 0. So this is 0, so they're saying 1/2 times 0 minus, what is log base 5 of 5? 1. So this is 2 times 1. So 1/2 times 0 is 0, minus 2 times 1 is 2, so your answer is -2. Okay, but again, if you want to do it the other way, you could do it the other way. I just think it's so much more work. So we're going to keep moving. Letter D, last one of these. 2 log base 8 of 4 minus 1/3 log base 8 of 8. Okay. If you remember how to do this, it's definitely not like one that comes to people easily, but some of you, maybe it does come to you easily. You could totally do it that way. For those of you that don't see that, remember this is asking the question 8 to what power is 4? It was like the bonus question on your quiz, okay? So you gotta think 8 is a perfect cube, so 1/3. You would square that to get 4, so 2/3. So you could think of this right now as 2 times 2/3. Let's just keep going for those of you that did it that way. I'll show you the other way too, just because I feel like that isn't as easy for some. Log base 8 of 8 is what? 1. So you're saying 2 times 2/3, so 4/3, minus 1/3 is 3/3, which is 1. Okay, so your answer here is 1. If you don't like that way, you can set it up the other way. Again, not the easiest. You would move this 2 out front, or the 2 that's out in front, to an exponent. So it's going to be log base 8.
That's 7/3.
2/3, sorry. 2/3. So this would be log base 8. We're subtracting, so it's division. So we're going to divide. On top, you have 4 squared. On bottom, you have 8 to the 1/3. Okay? What's 4 squared? 16. 8 to the 1/3 is 2, right? Cube root 8 is 2. So log base 8 of 8, and then figure it out from there, it's 1. Neither one of those is super easy. Okay, last thing. Almost there. You guys are troopers. This one is dealing with a change of base. Okay. And here's the property. So for any positive, did I write that on the beginning? I didn't. Did I write that? I didn't. Sorry. I'm going to go back to the very beginning real quick and just tell you this. For these M, N, and B are positive, and B doesn't equal 1. Okay? M, N, and B are positive. B does not equal 1. Sorry, I just realized I never wrote those when I saw them here. Can I move from that? Okay, thank you. That's a lot of notes, guys. Whew. Okay, change of base. Here's what it says. For any positive numbers, positive again. Is it really hot in here? I am so hot. M, B, and C. And where B does not equal 1 and C does not equal 1, this will be true. Log base B of M, okay, is going to be written as log M over log B. Another property for you. Okay, so if we need to turn it into two separate logs, you can say log M divided by log B. Okay? And these ones are pretty simple. I just have two quick examples for you. First one, if I say, oh, by the way, you might get your calculator out for this. Parentheses are huge on this. If you don't put parentheses in somewhere, you're going to get really kooky answers, okay? I don't know why I just used the word kooky. Yes? Nope. I don't have C. I don't know why I put a C there. Hold on. Sorry. Don't worry about this, because you're not going to see C in my setup right now. Okay, here's what you do. Log base 81 of 27. Okay? If you look at the property, how would you set this up? Log 27 divided by log 81. Okay? The only reason this is a difficult problem is because people forget parentheses and it doesn't work out nicely. When you plug this into your calculator, because that's all you're doing, you're plugging it in. Log 27, you have to finish off this parenthesis. Okay? So log 27 parenthesis divided by log 81. And that comes out to, anyone want to tell me? 0.75. Good. Okay. Second one, last one. You guys are troopers. Killed it today. Log base 8 of 32. How would you write that? Log 32, parenthesis, don't forget to finish that parenthesis, divided by log 8, okay? One thing to note here, this is not log 4. You cannot just divide these numbers. It doesn't work like that, okay? Log is doing something to that 32, right? We're talking exponents and things here. You cannot just divide them. So just be careful with that. Don't do log 4 and you won't get the same answer. Log base 32, sorry, not base, log 32 parenthesis divided by log 8, and you get, anybody? 1.6 repeating, so 1 point, if you rounded, 1.667, or if you wanted to write it as an improper, that's 5/3, 1 2/3, right? Either way is fine. You could technically do this by hand, right? 8 to what power is 32? So if you didn't want to do this property, you could do it by hand. Anybody know? Well, you know what the answer is. It's 5/3, right? If you took the cube root of 8, you'd get 2, and then 2 to the 5th power. So cube root and 5th power, when you multiply those together, you get 5/3. So there is potential to do them by hand, but why when you could just plug them into your calculator, right? Okay.